Picture this: a world where the sun never sets on one side, while the other remains locked in eternal darkness. Where the boundary between these two extremes creates a ring of perpetual twilight, perhaps the most habitable zone in the entire galaxy. This isn't science fiction. This is Kepler 442b, a real planet orbiting a distant star, and today we're going to explore what alien life might actually look like there. 1,200 light-years away from Earth, there's a planet that might harbor life forms unlike anything we've ever imagined. But here's the fascinating part: the same laws of physics and chemistry that govern life on Earth would shape any creatures living there. So while the life forms might be alien, the principles behind their existence would be surprisingly familiar. Let me paint you a picture of this remarkable world. Kepler 442b is what astronomers call a super-Earth. Imagine our planet, but about 1.5 times larger and more than twice as massive. If you could somehow stand on its surface, you'd feel about twice as heavy as you do right now. Your muscles would need to work harder with every step, potentially leading to very different evolutionary paths for any life that calls this world home. Now here's where it gets really interesting. Kepler 442b orbits much closer to its star than Earth does to our Sun, completing a full year in just 112 Earth days. But before you assume this world would be a scorching wasteland, consider this. Its star is what we call an orange dwarf, much cooler and dimmer than our Sun. This creates what scientists call the Goldilocks zone. Not too hot, not too cold, but potentially just right for liquid water to exist. But here's the most intriguing possibility: Kepler 442b might be tidally locked to its star. Think of how our moon always shows the same face to Earth. This planet might work the same way with its sun. One hemisphere would bask in permanent daylight, while the other would exist in endless night. And right along the border between these two worlds, a band of eternal twilight that could be the most incredible habitat in the known universe. Imagine the creatures that might evolve in such an environment. On the day side, where temperatures could rival Earth's tropics, life might develop incredible heat resistance. Picture plants, if we can call them that, with mirror-like surfaces reflecting excess light, or perhaps organisms that have evolved to be nearly transparent, allowing light to pass through rather than absorb dangerous levels of energy. These creatures might move slowly and deliberately, conserving energy in their sun-baked world. The night side tells a completely different story. In this realm of permanent darkness, life would need to find energy sources beyond sunlight. Think of the deep ocean creatures on Earth, bioluminescent jellies, creatures that derive energy from chemical processes rather than photosynthesis. Now imagine an entire hemisphere of such adaptations. Creatures might communicate through patterns of light across their bodies, creating a living constellation across the dark landscape. But the real magic happens in that twilight zone, the Terminator line where day meets night. Here, temperatures might be perfect for liquid water, and the gentle, constant light could support photosynthesis without the harsh intensity of the day side. This could be where complex ecosystems flourish, possibly resembling Earth's forests, but adapted to the perpetual golden hour lighting. To help you visualize this, think about how different Earth's creatures are based on their environments. Polar bears evolved thick fur and fat layers for Arctic survival, while desert foxes developed large ears for heat dissipation and light-colored fur for reflection. Now multiply those kinds of adaptations across an entire planet where each region experiences completely different and constant conditions. The gravity difference alone would reshape how life moves and grows. Flying creatures might evolve differently, perhaps with stronger wing muscles or different wing shapes to overcome the increased gravitational pull. Trees and plants might grow shorter and sturdier, creating landscapes that would look both familiar and alien to our eyes. As we push the boundaries of our search for life beyond Earth, worlds like Kepler 442b remind us that life might not just exist elsewhere. It might be thriving in ways we're only beginning to imagine. Every planet teaches us something new about the incredible adaptability of life itself. The next time you watch a sunset, remember that somewhere over 1,000 light-years away, there might be creatures experiencing their own version of that same golden light, not for a few fleeting minutes but for their entire existence. In that perpetual twilight, alien eyes might be looking up at their own sky, wondering just as we are, what other forms of life might exist among the stars. The universe is vast, mysterious, and possibly teeming with life more incredible than we've ever dared to dream.